Basically, the landscape for viral vector production in manufacturing is currently, unfortunately, in suboptimal manufacturing process. The reason I'm saying suboptimal because both upstream produce very low production of any viral vector that you are producing from AAV, lentivirus, oncolytic virus, exosome, any vector that you are targeting for gene therapy. Also, the downstream is really low recovery yield, and not talking about the fact that the analytics is not there yet. So there is a lot of need for rapid analytics so people will make fast and rapid correct decision moving forward with the process development. So basically on the major challenge because of this suboptimal manufacturing process is the capacity. So basically you can increase your volume for the bioreactor and you are not getting enough vector that needed based on the demand for several indications that you are using for therapeutic. That's due to low cell density, that's the HEC293 cells. It's not growing like the CHO in the monoclonal antibody. It is due to the fact that you are still using transient transfection expression platform that is not efficient in terms of the productivity of the virus, and also the virus is associated, for example, with AAV to the cells, and you have to go with lysis process that give a lot of toll and turbidity, viscosity to the downstream people. So this is number one is capacity because of the low supply for high demand in this field. The second one, I would say the challenge is scalability. Because of the nature of the process that you have to do transient transfection, lysis, and so on, most of the processes are not scalable, and people are struggling to meet the demands because of that. In addition to that, you have all the challenge of the cost, all the reagents that are cost enormous amount of money, and we need to drive that down, and the risk that you have because the process must be in closed system, automated system, sterile, because the product is a virus. So you cannot do viral clearance at the end of the process. So therefore, you have to do all kind of risk mitigation strategy in order not to compromise on the safety and the quality of the product that go to the patient, and we cannot afford that one. So this is basically the major challenges that I see due to the suboptimal manufacturing processes for viral vector.